Welcome to Chem Plus. Welcome to Chem Plus. Today we've decided to look at some phenol reactions, right? Before we do that, we want to try and name these compounds. For example, what's the name of that one? If you want to pause the video, you can pause the video and think about the names of these three compounds. I'll give you 5 seconds. The first one is 4-nitrophenol, because the OH group attached to the ring makes it a phenol, but if we say 1, 2, 3, the nitro is on position number 4, therefore 4-nitrophenol. The second one, we've got bromines on position 2, 4, 6, 2, 4, 6. So it's going to be 2,4,6-tribromo phenol. And on another day, in an exam, they might ask you why, when phenol reacts with bromine, why do we have a bromine there? You'll have to do a bit more reading about directing groups. The OH is a 2,4 directing group. Anything that's coming to this ring will go to position number 2, position number 4, or position number 2 if you. So that's why it forms those 2, 4, 6 positions. And what's the name of the last one? It looks like a salt to me. Sodium phenoxide. Now, the purpose of this is to look at the suitable reactions. What do we need? What do we need here? For phenol, what's phenol reacting with to form 4-nitrophenol? What do we have there? Nitric acid. Unlike benzene, you will need to generate an electrophile, NO2+, but phenol can just react with dilute nitric acid at room temperature to form 4-nitrophenol. If you use concentrated nitric acid, then you are going to have more groups, more NO groups, multiple substitutions on the ring. If you use concentrated nitric acid, you're going to have multiple substitutions on the ring. What do we need to form 2,4,6-tribromo? We need bromine. On another day, in an exam paper, they will ask you, if this reaction takes place, what do you observe? With alkenes, the bromine is decolorized. With phenol, the bromine is decolorized, but what else do you see? This whole compound you see here is a white precipitate. It's a white precipitate. So the difference between the reaction of alkenes and the bromine, alkenes just decolorize the bromine. Phenol decolorizes the bromine, but also forms a white precipitate. And finally, what do we need for this reaction here? What do we need? Phenol is a weak acid. This phenol you see here is a weak acid. So it can react to sodium hydroxide, or it can react with metals. You know, acid plus metal, you form salt plus hydrogen. Or it can react with concentrated, stronger alkalis to form salt plus water for sodium phenoxide. So what we need there is, mind you, phenol does not react with sodium carbonate. It's a weak acid. It's not reacting with sodium carbonate, which is a weak base. So here we need sodium and sodium hydroxide. I hope this helps. Well done.